Hello and welcome. Today's topic is the sources of firewood and timber. Trees provide us with wood, a natural and renewable resource used for a diversity of purposes. With a growing human population, the demand for wood and its products is constantly increasing, and large areas of natural forests have therefore been exploited. Historically, humans have used wood for fuel, lumber, paper, and other wood products. The demand for wood has grown substantially in the past 25 years and is expected to grow further with increase in human population, which is projected to exceed 9 billion by the year 2050. Forests have arguably played a bigger role in the development of human societies than any other resource. For almost 3 billion people, wood is the main energy source for heating and cooking. Many countries, notably Bangladesh, Nepal, and Pakistan, face a growing shortage of wood for this basic purpose. Wood, a unique among world's important raw materials, virtually used by everyone in diverse ways, owes its origin to trees. A tree is a large, long-lived woody plant that usually, but not always, has a single main self-supporting stem called a trunk or a bole, which gives off spreading branches, twigs, foliage, etc. In fact, each letter of the plural word trees has a logical meaning. T, that would stand for timber, that's the first and the foremost use of trees. R stands for restoration, reclamation, and rejuvenation of denuded and disturbed soils by using trees to control soil erosion and desertification, protect watersheds, improve soil nutrient status, and retain moisture in the soil. E stands for ecological, eco-developmental, and environmental use of trees for effective and efficient purification of the environment because trees act as oxygen banks and eliminate air pollutants. E also stands for abating or moderating temperature, noise, and wind as trees act as environmental screens, thus affecting the microclimate, for harboring wildlife, for maintaining biodiversity, and for conserving energy. The other E stands for educational and recreational value in gardening, landscaping, bioaesthetic planning, art, culture, and religion. S stands for source of sustenance, that is, it provides food, fuel, fodder, fertilizer, fiber, medicine, tannin, dyes, oils, etc. Wood produced by conifers, taxets, and dicots is called pinoxalic wood. It's compact and dense with narrow rays, pith, and cortex, hence commercially very useful. The commercially useful woods are called timbers, and timber that is used for building purposes is called lumber. Tectona grandis, commonly known as teak, and Cedrus deodara, known as deodar, are respectively considered as the best angiospermic and gymnospermic timbers in the world. Wood obtained from timber trees is used for construction and other miscellaneous purposes like agricultural implements, boat and shipbuilding, carts and carriages, carving and turnery, cooperage, electric poles, engraving and printing blocks, furniture and cabinet work, matches and matchboxes, mathematical instruments, musical instruments, packing cases and boxes, pencil and pen holders, picture framing, railway carriages and wagon building, railway sleepers, rifle pods, shoe heels and boot lasts, shuttle, sports goods, tea chests, toys, etc. The anatomical structure of wood affects strength properties, appearance, resistance to penetration by water and chemicals, resistance to decay, pulp quality, and the chemical reactivity of wood. To use wood most effectively requires a knowledge of not only the amounts of various substances that make up wood, but also how those substances are distributed in the cell walls. Because of the great structural variations in wood, there are many possibilities for selecting a species for a specific purpose. Some species, like spruce, combine lightweight with relatively high values for stiffness and bending strength. Very heavy woods, like the lignum vitae, are extremely hard and are resistant to abrasion. A very light wood, the balsa, has high thermal insulation value. Hickory has extremely high shock resistance. Mahogany has excellent dimensional stability. Now we'll talk about wood as fuel. Wood has been traditionally used as fuel. Wood fuels play an important role in India as they do in many other parts of Asia. Annual consumption in the country as a whole is estimated at 220 million tons up to 300 million tons, which is worth some 9 billion US dollars, and this amount is increasing. At present, wood fuels account for about 20 to 30% of all the energy used in India, and more than 90% of this is in the domestic sector. However, wood fuel is more than just a commodity being consumed. Instead, it's being supplied, processed, and traded. This has many implications: economical, social, environmental, etc. Indeed, wood is likely to continue as the most important fuel for rural areas of the developing countries, and the demand will increase enormously in the coming decades as the fossil fuels are becoming more scarce and expensive. It is the most accessible and cheapest source of energy for most of the rural people. Most woods burn, but there are several properties that differentiate the relative value as a source of fuel. Density is the most general gauge of wood burning quality. The heavier the wood, that's the drier the wood, the greater its calorific value. The heat given is enhanced by about 20% by the resins found in conifer woods and by the oils and gums sometimes found in the hardwoods. Green woods have lower heating value than dry wood because energy is used in evaporating the moisture. The loss may reach up to 20%. Some of the species having characteristics that serve mainly for firewood are Albizia falcateria, because of its rapid growth, vigorous coppicing, and usefulness when grown in combination with agricultural crops. It's considered for firewood. The wood is light, soft, and lacks strength. Its specific gravity ranges from 0.24 to 0.49. It makes good charcoal with its calorific potential value ranging from 2,865 to 3,357 kilocalories per kg. The second one is Eucalyptus brassiana. It's a hardy, fast-growing tree adapted to a variety of site conditions in the lowland tropics. It tolerates periodic flooding and readily coppices. Eucalyptus brassiana is a fast-growing species with the capacity to produce coppice shoots. The wood is moderately dense. The third one is Hibiscus stillaceus. The wood of this fast-growing tree is used chiefly for fuel, although the fibrous bark is much used for cordage. The trees sprout from stumps and when cut back produce long, vigorous shoots from which quantities of rope can be made. The wood is used principally for fuel. It's also employed as firewood. The tree is recommended for planting on poor soils as a firewood resource. The wood has a specific gravity of 0.6. Coppicing is remarkably swift and profuse, with multiple long stems arising from cut stumps. The fourth one is Psidium guajava. It is the commonly known guava. In high population areas, guava should be a good tree for use as firewood. It coppices readily, and its growth rate is rapid at first and slower as the tree ages. Its ability to withstand repeated cutting makes it an exceptionally fine firewood. The hard, strong, heavy wood has a specific gravity of zero point 0.8 and makes excellent firewood and charcoal. The gross calorific value per gram of dry matter is 4,792 kilocalories with 0.85% ash. After this, we'll study Acacia decurrens. Acacia decurrens yields excellent fuel wood and charcoal and is proved suitable firewood in many countries. The wood is not suitable for sawn timber because of its small dimensions. It does make a good firewood though, with a specific gravity of 0.50 to 0.70. According to one report, it has a calorific potential of 3,530 to 3,940 kilocalories per kilogram. Then we have Eucalyptus terraticornis. It grows rapidly and withstands periodic flooding for short periods. It copices vigorously and is one of the principal eucalyptus grown as fuel wood. The wood is hard, heavy, and strong. The tree produces first-class fuel wood, which also makes good charcoal. Coppice regeneration has been widely used, and it can be done 3 to 4 times on a 10-year rotation. Melia azadirec. This China berry is well known and has already been planted in many countries as an ornamental plant. Its quick growth and small dimensions make it a very good choice for fast fuel wood production for household needs. In the Middle East, the species has already been used for this purpose. It's planted in reforestation projects in Thailand for veneer and fuel, and in Assam it's grown on tea estates for fuel. Its specific gravity is about 0.66 and the calorific value ranges from 5,043 to 5,176 kilocalories per kg. The other one is Robinia pseudoacacia. It's also known as black locust. It's quite fast growing. It can be planted and regenerated easily and is often used for afforestation of gullies and surface mined areas. As firewood, black locust is popular for its high caloric value and its good combustibility even when it's wet. It's slow to ignite but burns like coal with a bright blue concentrated flame. The specific gravity of the wood is 0.70 to 0.80 and it's well suited for charcoal production. In India and South Korea, the species has been used to establish fuel wood plantations. Sapium sebiferum is another source. This Chinese tallow tree holds promise as a highly useful species for short rotation, intensive silviculture. It's a fast-growing insect and disease-resistant tree and tolerates a wide range of soil conditions, including poorly drained and saline soils. Prolific sprouting occurs from stumps and injured roots. Moisture content of tallow tree wood ranges from 41 to 45% on wet basis. Specific gravity ranges from 0.37 to 0.48. Energy values range from 4,134 to 4,277 kilocalories per kg. The wood burns well in wood stoves or fireplaces if it has been allowed to dry adequately. It produces a pleasant odor while burning. The other source is Ailanthus excelsa. It's a fast-growing tree that regenerates well by coppicing. It provides valuable fodder and shade and makes good shelter belts. Although it's generally unrecognized as a fuel tree, its pruned branches and cut stems are much used as fuel wood in India, its native region. The wood is fairly light. Its specific gravity is 0.45 and therefore is not an ideal fuel. However, as already noted, it is used as firewood. The other one is Dalbergia siso. Dalbergia siso is moderately fast-growing tree that adapts well to semi-arid conditions and produces first-class firewood. Its timber is highly valued for construction and general utility purposes. Under savanna conditions, the trunk is usually crooked, but it is much sought for furniture, shipbuilding, and fuel. Sisal wood is classed as an excellent fuel. Calorific values of the sapwood and the heartwood are 4,900 and 5,200 kilocalories per kg respectively. Specific gravity is between 0.64 and 0.7 depending on the locality. The wood is also suitable for making charcoal. As fuel wood, it's grown on a 10 to 15-year rotation. Poplar euphragtica grows fast. Annual diameter increments of 4 to 5.3 centimeters have been measured. It can tolerate a high degree of salinity and extremely arid and continental type climatic conditions, provided the subsoil is moist. It also grows on land that is seasonally flooded and on which no other form of cultivation appears possible. The wood is moderately dense. Its specific gravity almost going up to 0.48. The calorific value is reported to be 5,019 kilocalories for the sapwood and 5,008 kilocalories for the heartwood. The other source being Sesbania sesban. Sesban is a fast-growing short-lived tree that regenerates rapidly after pruning. It has a tendency to form root nodules by symbiotic association with soil bacteria capable of fixing atmospheric nitrogen. In Africa and in India, where fuel is scarce, the tree is sometimes planted to provide firewood, which is used especially for boiling the sap of the sugar palm. The wood yields an excellent gunpowder charcoal. Now we'll talk about wood as timber. Number of woody species occurring in the country is almost 4,000. Of the estimated 4,000 woody species, nearly 1,200 attain tree size and are potentially capable of producing timber. However, majority of the species occur either occasionally or in inaccessible regions. Till about only 25% of the tree species which were well known have been exploited for timber. Shortage of the well-known timbers as well as technological advances have considerably changed the pattern of timber utilization. The shift is towards use of reconstructed wood products such as plywood, blockboards, flush doors, particle boards, etc., in addition to the use of chemically treated, less durable timbers. This has resulted in use of large number of species and small-sized timbers which were not considered to be of commercial value earlier. Now we'll talk about those timber plants which have been used for commercial purposes in India. The first one is Artocarpus hirsutus. Its wood is elastic, close-grained and strong. It is used for ordinary building, construction, structural work, paving, furniture, etc. The second one is Terminalia arjuna. It's heavy and strong and used for beams, rafters, and posts. The third one is Anogeissus latifolia. It is very strong, hard, and tough. It takes a smooth finish but usually cracks. The fourth one is Acacia nilotica, the subspecies being indica. It's strong, hard, and tough, and it takes a good polish. It's used for bodies and wheels of bullock cart, agricultural instrument, tool handles, and well curbs. Then we have Mimosops elengi. It's close-grained and tough. It's used for making cabinets. After this, we have Ficus bengalensis. It's strong and durable only underwater. After this, we come to Lagerstomia parviflora. It is strong and takes up a smooth surface. It's used for building constructions, boat building, and furniture. After this, we'll talk about Pterocarpus marsupium. It's coarse-grained, durable, strong, but difficult to work. It's used for ordinary building construction and for cartwheels. Then we'll talk about the Casuarina species. They grow straight and are strong and fibrous. They are, however, badly twisted and so often used for scaffolding and as posts for temporary structures. After this, we come to Cocos nucifera. It takes good polish and is used in poles, piles, furnitures, as well as formwork and concrete construction. Then we'll come to deodar, that is Cedrus deodara. Deodar is the most important timber tree providing softwood. It can be easily worked and is moderately strong. It possesses distinct annual rings. It's used for making cheap furniture, railway carriages, railway sleepers, packing boxes, structural work, etc. After this, we come to Hopia pariflora. It's extremely strong and tough and difficult to work. However, it can be seasoned easily and is durable. It has been used for various purposes like ordinary house constructions, railway sleepers, piles, and boat buildings. After this, we'll discuss Ulmus walliciana. It's moderately hard and strong. It's used for doors and window frames and carts, etc. Our next source is Mesua feria. The ironwood is durable, though it's very hard and it's not easily worked. It even resists penetration of nails. It is used for ordinary house construction, bridges, piles, agricultural instruments, railway wagons, and railway sleepers. After this, we'll talk about Xylea xylocarpa. It is very hard, heavy, and durable. It's difficult to work with, and it also requires slow and careful seasoning. It's used for railway sleepers, agricultural instruments, paving blocks, and heavy construction. After this, we'll study Mangifera saesis. The wood is compact and even grained. It's moderately strong and easy to work. It takes a good finish and maintains its shape well. It has many uses including plain furniture, boat construction, well curbs, door panels, cabinet making, and musical instruments. After this, the next species that we are going to discuss is Lagerstromia flos reginae. It is hard and durable and can be easily worked. It takes a good finish and is used for house construction, boat building, railway carriages, cart making, and scaffolding. Our next species is Autocarpus heterophyllus. Its wood is heavy and hard, is durable underwater and in damp conditions. However, it cracks if exposed to direct sun. It's used for piles, platforms of wooden bridges, door and window panels. After this, we'll talk about the Swietenia species. It takes a good polish and is easily worked. It's durable underwater. It's most commonly used for furniture, pattern making, and cabinet work. Now we come to Mangifera species. The mango tree is well known for its fruits. Wood is easy to work with and it maintains its shape well. It's moderately strong and it's often used for cheap furniture, toys, packing boxes, cabinet work, panels for doors, and for windows. After this, we come to the Morus species. Species of Morus have strong, tough, and elastic wood. It takes up a clean finish. It can be well seasoned. It is turned and carved easily. Mulberry is typically used for baskets and sports goods like hockey sticks, tennis rackets, and cricket bats. Our next species is Quercus, that is the oak. Oak is strong and durable with straight silvery grain. It's used for preparing sports goods. Our next species is Pinus. Pinewood is hard and tough, except white pine, which is soft. It decays easily if it comes into contact with soil. It is heavy and coarse-grained. It is used for pattern making, frames for doors and windows, and for paving material. White pine is light and straight-grained and is used in the manufacture of matches. Our next species is Delbergia latifolia. It's strong and tough and close-grained. It's a handsome wood that takes up a high polish. It maintains its shape well and is available in large sizes. It's used for furniture of superior quality, cabinet work, ornamental carvings, etc. Our next species is Shoria robusta. It's hard, fibrous, and close grained. It does not take up a good polish, it requires slow and careful seasoning. It's durable underground and water. It's used for railway sleepers, shipbuilding, and bridges. Our next species is Santalum. It has a very pleasant smell. It's commonly used for agricultural instruments, well curbs, wheels, and mallets. Our next species is Chloroxylon swietania. It's very hard and durable. It's close grained. It's used for furniture and other ornamental works. Our next species is Bombax. It's a loose grained, inferior quality wood. It's light in weight. It's used in packing cases, the match industry, well curbs, and for cheap furniture. After this, the next species is Albizia. Its wood is hard and durable, and Cirrus wood is difficult to work. It's used for well curbs in salty water, beams, posts, and furniture. Our next species is Dalbergia sisso. The wood is strong and tough. It's durable and handsome and can maintain its shape well. It can be easily seasoned. It's difficult to work, but it takes up a fine polish. It's used for high quality furniture, plywood bridge piles, sports goods, railway sleepers, and so forth. It is a very good material for decorative works and carvings. Our next species is Picea. Spruce wood resists decay and is not affected by the attack of marine borers. It is, however, liable to shrink, twist, and warp. It's used for piles underwater and formerly for aeroplane construction. Our next species is Heritiera fomes. Its wood is hard and tough. It's difficult to season and work. It is elastic and close-grained. It's strong and durable. These qualities make it well suited for boat building, piles, poles, tool handles, and carriage shafts. Our next species is Tamarindus indica. Tamarind is knotty and durable. It's a beautiful tree for avenue and gardens. Its development is very slow, but it ultimately forms a massive appearance. Its fruit is also very useful. It's used for agricultural instruments, well curbs, sugar mills, carts, and brick burning. Our next species is Tectona grandis. Its wood is moderately hard. The teak is durable and fire resistant. It can be easily seasoned and worked. It takes up a good polish and is not attacked by white ants and dry rot. It's among the most valuable timber trees of the world, and its use is limited to superior work only. The next species is Tuna ciliata. It can be easily worked. It's light in weight. It's used for products such as furniture, packing boxes, cabinet making, and door panels. With this, we come to the end of today's lecture. We hope you have made the most of it. We'll see you next time. Goodbye.